This is an A-level pure question on forming and solving differential equations. A spherical mint of radius 5 millimeters is placed in the mouth and sucked. 4 minutes later, the radius of the mint is 3 millimeters. In a simple model, the rate of decrease of the radius of the mint is inversely proportional to the square of the radius. Using this model and all the information given, part A, find an equation linking the radius of the mint and the time. You should define the variables that you use. Okay, so what we're going to do is take the bits of information from the question and use that to form a differential equation. So this question is about the change in the radius over time. Change in radius over the change in time. Now that radius we're told is decreasing, so we put a negative for decrease. And then it says it's inversely proportional to the square of the radius. So inversely proportional k over r squared. Now the question does say that you need to define your variables as you go along. So I'll put r is equal to radius. And I've also got k, which is equal to my constant. Now we need to turn this into an equation which is r equals something. To do that, we need to first of all find a general solution to this differential equation, and we do that by using a separation of variables. So we're going to put all the r terms on one side, so I'll have r squared dr times both sides by r squared is equal to, I'll leave the negative k where it is, and then times both sides by dt. I'm now going to integrate both sides like this. The r squared will become 1/3 r cubed, and the negative k integrate with respect to t will become negative kt, and then I'm going to have plus c, my constant of integration. And I need to work out what both of these constants are. I can do that by looking right at the beginning here of the question, where it says that when the mint was first put in the mouth, in other words when t is 0, we're told that the radius of the mint is 5, and we're told that 4 minutes later, so when t is 4, the radius is 3. So we're going to substitute both of these bits of information in to find k and c. So let's start with the t is 0, r is 5, and see what that gives us. So when r is 5, we'll end up with 1/3 times by 5 cubed is equal to negative k times by t, which is 0, plus c. That's fairly straightforward. That gives c is equal to 125 over 3. We'll now use the t equals 4, r equals 3 bits of information. And this time what we'll get is 1/3 times by 3 cubed is equal to negative k times by t, which is 4, and plus c. Now I've worked out c, so we'll put that in. So plus 125 over 3. So we can rearrange that and solve it. So we can work out what k is. So I've got 100 and not 100 and anything. I've got 1/3 of 27, which is 9. So I've got 9 is equal to, or actually let me bring across, take away the 125 over 3 is equal to negative 4k. So we can divide both sides by negative 4 here to work out what k is. And that gives us k is equal to 49 over 6. So I have my value of c, I have my value of k. They can be both put into this equation here. So what I'll have is 1/3 r cubed is equal to negative k, so that's negative 49 over 6 t, plus c, which is 125 over 3. Now it's acceptable to leave my answer in this form because the question says we just want an equation linking the radius of the mint and time, which is what we've got here. It doesn't ask us to write this in the form r is equal to. So this is perfectly acceptable as an answer for this part of the question. Part B, what we're asked to do is hence Find the total time taken for the mint to completely dissolve. Give your answer in minutes and seconds to the nearest second. Okay, so the mint will dissolve basically when the radius is equal to 0. So mint will dissolve when r is equal to 0. So that's what we're going to substitute into the equation that we formed in part A. So what we'll have is 1/3 times by 0 cubed is equal to negative 49 over 6t plus 125 over 3. So we want to solve this for t. So we've got 49 over 6t is equal to 125 over 3. Solving that for t, I get as a fraction 250 over 49, which is 5.10204 and so on. So we need to give this answer in minutes and seconds. Well, I can see that it's 5 minutes. Now what we need to do is to take this decimal part here and times it by 60. So I take this part, times it by 60, because it's going to be a fraction of a minute, and that gives me 6.1224 and so on. So 6 and a bit seconds. We want the answer to the nearest second, so 5 minutes and 6 seconds. That's how long, according to this model, is going to take for this mint to completely dissolve. And lastly, part C, suggest a limitation of this model. So there are lots of valid reasons you could give. I've just suggested a few here. So the mint might be chewed. So as you've got it in your mouth, you might decide to chew it up, in which case, like, it's not going to, well, it's going to dissolve much quicker than the time we've worked out here. The shape of the mint may not always be spherical. So as you've got that mint in your mouth, it may change shape. This assumes that it's always a sphere. And the model isn't valid beyond the time the mint completely dissolves. So for example, if you put in a large enough value of t, you get a negative radius. So obviously it's not valid beyond that point. But there are other reasons you can give, as long as they're sensible and they're valid limitations of the model, it would be worth a mark.